Suppose that x represents one of two positive numbers whose sum is 45. So the idea is that the other positive number is y, and maybe you even wrote this x plus y equals 45. And when you solve for y is 45 minus x. The product is x times y, and that's where you got this from, because it's x times 45 minus x. Okay, so that's good. No issues there. For what two numbers is the product equal to 504? Determine analytically. So you started this, it's not finished. You allowed to use a calculator on this?
Yes.
You are? Okay. So you're trying to find two numbers that multiply to 504, but add up to negative 45. So they're both going to be negative. Like, I actually find it pretty hard to factor big numbers like this. So you can guess and check, like you can get your calculator out and you can take like 504 and divide it by 2. And like, obviously that works. That's 2 and 252. 3 actually works as well. 168. Okay. 4 and 126. And you keep going to this, but you eventually need a calculator. It's like, so you're looking for the ones that are minus 54 apart. The other option is to use like the quadratic formula here. Did you talk about either of those in class, or?
Yeah, a little bit.
Okay, and then yet there's a third option, which is to graph this thing. So which do you want to do? So I laid out, we can factor, quadratic formula, or graph.
We can factor it.
Okay, so we got to keep going here. So 504 is divisible by 6 because it's divisible by both 2 and 3. Okay, so that's 6 and 84. And then it is probably divisible by 8 because so that's 8 and 63. And we just have to keep going here. It looks like it's divisible by 12 also. Oh, it's divisible by 9 because they both add up. There's 9 and 56. And then we just have to keep going here. So we'll go 12, 12 and 42. I don't know if it's 14 is going to work. Did 14 and 36. So these are all going to be negative. So we're looking for the ones that add up to negative 45. So we're getting closer because negative 14 and negative 36, they add up to negative 50. So we're getting really, really close. We're going to try 16. 16 didn't work. I bet 18 does. 18 does 18. And 28. Wait, we don't, do we really not? Is it not? It's not, those are, maybe I missed one here. Maybe it's 17 and nope. Is this the right? No, 504. Okay, so and then eventually you get, believe it or not, got it here. It's 21 and 24. So this factors into x minus 21, x minus 24 equals 0. Okay, so then you set each one equal to 0, x minus 21 equal to 0, x minus 24 equal to 0, x equals 21, and x equals 24. That's, fair amount of work for this one. Okay, 13 looks correct. Do you want me to go through this?
I think that one is fine. I had problems with 16.
Sure. Yeah, 16 is 3 parallel. Okay. All right. No, sorry. They seem to they just scan these things over and over again, and they never, pictures don't come out very clear. Okay. pasting this in here. So there's 3 of these.
Mhm.
Typically we call this is going to be y. All right. So there's 600 feet of fencing available. So we know that means that x plus x plus x, these 3 plus y equals 600. That's what it means there. There's no y over here because the idea is that the river doesn't need a fence because the animals won't go into the water.
Mhm.
I guess that's reasonable. So question A, it says, what is the length of the remaining piece of fence in terms of x? And in other words, basically it's saying to solve this equation up here for y, okay, because the y is the remaining piece of fence. Really, it means solve for y. So we've got 3x plus y equals 600. So y equals 600 minus 3x. All right, any questions on that? Is that okay?
No, that makes sense.
All right, and then question B, determine a function. Okay, so they're really, I think your brother had one of these problems like this, that it was like they really work you all the way through these through this. So the area is x times y. Now, how did I come up though with that? This thing is a rectangle up here. It's a
Mhm.
rectangle. I know it's got those 3 pieces here, but or these 3 horizontal ones, but it's still x times y to get the whole area there. Okay. Now, you don't want it in terms of x and y. So you want to use the fact that this is y. So it's x times 600 minus 3x. So in general, you typically write 2 equations when you're doing these problems, and then you substitute one into the other. And that's what we did. That's what we did here. Got some allergies
Yeah, me too.
tonight. Apologize for the sniffling.
You're good.
All right, what dimensions for the total enclosed region would give an area of 22,500 square feet? So like the last one, you're going to set this equation you just found equal to this number here. That's the area. So it's x times 600 minus 3x equals 22,500. So when we factor this, we get minus 3x, I'm sorry, when we distribute, minus 3x squared plus 600x, move the 22,500 over, so minus 22,500 equals 0. Now, believe it or not, this kind of helps, I guess, each of these is divisible by -3. So we can say x squared minus 200x plus 7,500. Okay, now it says to determine your answer analytically. So that means we have options here. The options are factor or quadratic formula. When it gets this big, at some point, you know, we've got to find numbers that are 200 apart. Like, I don't know, it, like, to me, this isn't all that obvious. Like, it's like, well, 50 and 150 are 200 apart, are 100 apart. So that doesn't work. So we're looking for something, you know, something else. Let's just use the quadratic formula on this one. So as a reminder, the quadratic formula is x equals minus b plus or minus the square root b squared minus 4ac all over 2a. And what I usually encourage students to do is to write the values up above here. B is minus 200 and c is 7,500. And the hardest part of the quadratic formula is once you get it down, is just entering it into your calculator correctly. It's easy to make a sign error. This should work out nicely, believe it or not. Yeah, over 2 times 1. If you have a calculator handy, I would recommend using it here. I'm also going to enter it in. Interesting. Okay. And then the other one. Yeah, so I got 50 and 150. That's, oh, they have to be 200 apart. Okay. So it's -3 parentheses x minus 50, x minus 150. Did I get a sign wrong? I don't know. That doesn't seem right.
No, that's the same thing.
Okay. So you set these equal to 0, and we have x equals 50 or x equals 150. Now, we didn't do something early on here. It said in one of these earlier questions is to give any of the restrictions here. Basically, the area has to be greater than 0.
Mhm.
And so you basically say, okay, I'm going to set each of these parts greater than, so x has to be greater than 0, check. 600 minus 3x has to be greater than 0. So when you move some things around, you get 600 greater than 3x, divide by 3 on both sides, so you get x less than 200, or x less than 200. So that's your restriction. Your restriction here is that it's between 0 and 200. And you do that by setting each of these pieces greater than 0. All right. Use a graph to find the maximum area that can be enclosed. So this one is a little bit different. So the original function, the area function, was x times 600 minus 3x. So this is what we would graph. So I know I'm going to just graph it here in Desmos, and then I'll show you what to look for, because we're not really emphasizing the graphing today, so I'm not going to worry about getting the calculator out here. We can definitely do that if we need to. 0. All right, it's a little too big. Let's go divide by 2. Okay. All right, so here is the graph. I'm snipping it in now. And what I've done for you is I've identified the vertex. Oop, that's not there, that's readable. So this is the vertex. And the vertex always gives you the min or the max. So in this case, it gives you the max. So the x value that it's maxed at here is 100. So when you put 100 back into this equation, you end up getting the 30,000.
Mhm.
So it's when x equals 100, the area equals 30,000. How is that? Anything you'd like to clarify or go over again on that one?
No, that makes sense now.
Okay, so in all of these questions, let me just summarize real quick. Now we're on to the second page.
Mhm.
You generally write, one equation, then another equation, and then you substitute in, and that's what we did. That's what we did in number 12. Number 16, we wrote an equation, then we wrote the area equation, and we substituted in, and that's generally your process here. They're not often very different, question to question.
Mhm. Okay.
Okay. So 617 looks good. Do you want me to explain any part of 17 or go over it again, or do you?
No, that makes sense.
Okay. The main thing here is that I'm seeing that that you didn't put down, but it looks like you understood is the vertex formulas.
Mhm.
So there's the vertex formula. The x value of the vertex is always at minus b over 2a. And like in 16b, I just want to make sure you see that was minus 44 over 2 times negative 16. That's how you got the 1.375. You know, that was your b and that was your a. All right. So we'll go to 18 then. 18. So here's 18. And then what is the initial height of the golf ball? Okay. So the initial height of the golf ball, whenever it says initial, that means that time is equal to 0. And you're supposed to be interpreting that, meaning you have to know that on your own. So it's essentially asking, what is h of 0? Well, h of 0 means you're putting 0 in to this equation up here, minus 16 times 0 squared plus 60 times 0. Have you ever like gone to Top Golf, or have you ever hit a golf ball?
Yes.
Yeah, this isn't quite true because there's usually a tee, but they say, you know, essentially it's on the ground. I mean, you can hit one on the ground too at Top Golf if you've ever been there.
Yeah.
So that's reasonable. All right. B, how high is the golf ball after 15 seconds? Or I'm sorry, 1.5 seconds. So you hit a ball and later on it's up in the air. Like if you were to graph the trajectory of the golf ball, it goes up and comes down. Maybe yours looks more like that. You know, maybe you go under it, it goes up like that. Well, you know, who knows, right? But 1.5 seconds later, t equals 1.5. Your height is h of 1.5. You're putting 1.5 into the original function. And you said you can use a calculator. You just want to be really, really careful with you know, parentheses and order of operation. You notice I always show substitution in parentheses. I strongly recommend that. It seems to avoid some of the issues that come with sign errors. So just you know, double check your answer here. 54. Now, because it's a word problem, a story problem, we need to know the height, and that is that in feet, meters, inches. In this case, it's in feet. So your instructor is emphasizing this right now. Is that okay? Any questions on that?
No, that makes sense.
Okay. Find the maximum height of the golf ball. All right. So the maximum height, I mentioned this in the previous problem. If you were to graph it, it's the vertex. So what is the x coordinate of the vertex?
It would be 60.
It's minus b over 2a. Now you just said 60. Did you already calculate it?
Oh no, I thought that is the B, but I haven't calculated.
So yeah, it is the b, but it's also got the 2a. So if you end up taking calculus, you'll learn why this works. If you don't, then you don't ever need to know this. So 2 times negative 16. So this is the where it happens. This is or I'm sorry, or in this case, the when it happens. When does it happen is at 1.875 seconds. Okay, but that's not the answer. That's, and you remember this in geometry, like it would ask you like solve for the angle and you'd find x, but then you have to put x back in. It's the same idea here. Like this is when it happens. The maximum height is h of 1.875. So you have to go back and you have to put that number back into the original equation. So it should be more than 54 feet because at 1.5 seconds, it's still on the way up. do you have an answer for that?
I'm calculating.
Yeah, me too. Okay, so I get 56.25 feet. Please double check me. I do make mistakes, and I want to make sure you get the right answer, obviously, with this. Okay, can I move on to question 20?
Yes.
All
I
right,
got it.
great. Sometimes they ask you to write a sentence, so it would be like, after 1.875 seconds, the golf ball reaches a height of 56.25 feet. And you should be expected to be able to reasonably do that. Okay, a cylindrical aluminum can is being constructed to have a height of 4 inches. They tell you the height. And the can is to also have a volume 28 cubic inches. Approximate its radius. Okay, so this seems out of scope here. They're giving you the formula for a can. A can is like a prism. The base is a circle, pi r squared, and then you multiply by the height, which is the like protrusion or extension of it. So that's the volume. They give you the volume. The volume is 28. The height is 4, but they don't give you r, and they want you to find r, calculate r. So this is just a solve for r. This is like a literal equation where you just have to do whatever you need to do to get r by itself. So let's divide by 4 on both sides. And then divide both sides by pi. You can actually do that in the same step if you want. And then how do you undo a square? Square root. So it's the square root. Now you might recall either me or someone else saying, hey, it's plus or minus, but because it's a can, the radius has to be positive. So this is your like answer. And then we need units. So the radius is in inches. So it's the square root of 7 over pi inches. You can grab a calculator if you want. We don't know what we're supposed to round to, but we know we're going to get a decimal here. So, you could say r is approximately 1.49 inches if you wanted. This one's very different than the previous ones. Like, I don't know why this is here. Like normally, you get 2 equations and then you substitute one for the other, but that's what this is. Sometimes in these problems, they tell you like it's a square can, the height equals the radius. And then you end up like substituting in, because it looks like when you look at the original equation, it looks like you have 2 variables, but sometimes they tell you like, oh, the height and the radius are the same, so you substitute in for hr and you solve for r. I really don't know. Again, like this kind of seems out of scope. So okay, moving on to 41, unless there's nothing else to discuss. I'll just remind you, like, I can't see your body language, obviously. So if something is not clear, please tell me. You can chat me. You can just tell me stop, I don't understand, or need another one like this. Please, I definitely want to make sure you get everything you need out of this lesson today. So this is not useful. So if you're taking like a standardized test, one of the strategies is to avoid reading stuff that you don't need. This is really the question over here to the right. It's hey, here's the vertex. write the equation. Oh, and by the way, you need another data point. So the vertex is always h comma k. So if 4 comma 50 is your vertex, you already have 2 of the values. So your f of x is a x minus 4 squared plus 50. Okay, now there's one constant. X is the variable. Sometimes this is written as y instead of f of x. And I sometimes ask, like, how many letters do you have? 1, 2, 3. So to find a, you need another ordered pair. And that's why they give you this one here. So they tell you that 110 equals a 14 minus 4, because that's x and y, squared plus 50. All right, so let's do some simplification here. 14 minus 4 is 10. 10 squared is 100 plus 50. So if you subtract 50 from both sides, you get 60 equals 100a divide by 100, and a equals 0.6 or 3/5, whichever you prefer. And this is the key, is you have to know to put it back into this line up here, not the line below it. The line below it's just your work. We're trying to get a function out of this. So f of x equals 0.6 x minus 4 squared plus 50. So Gabriella, that takes us to the end of what you sent. Do you have some other things you would like to work on today?
Check. I do not have anything else.
Okay, so we have some time left. Would you like to do something else? Maybe check your notes, see if there's something else in class that was unclear.
Yeah, check. So I feel like she's gonna give us more questions like number 16. Which is like the river thing. So
Sure, yeah. So let's do another one like that. So here's your river. And the more common one is they tell you that they want to build a fence along a river, X and Y. And they say that someone bought 200 meters worth of materials. Okay. So what does that mean? What does that mean if there's 200 meters worth of materials? That means that these dimensions have to add up to 200. So it's like X plus 2Y equals 200. Now, they also do the following. They tell you, the question will say, what is the maximum area? So area is X times Y. So see how I mentioned before, you generally write two equations, and then you do something in one and substitute in the other. So here, believe it or not, we actually want to solve for X. It'll be slightly easier. This is just a little bit different. So we'll do it this way. So X is 200 minus 2Y. And then we're going to take that and substitute it in and here. So we have x 200. I'm sorry, I substituted in the wrong place. You can't substitute in for the variable for that one. So we're going to make this 200 minus 2y times y. So when you distribute the y in, you get minus 2y squared plus 200y, and that's your area function. I know this is in terms of y instead of x, but is this still clear what we've done?
Yeah. Where did the other y come from? The one out of the parentheses.
That's from this x times y right here.
Oh, okay, yeah. I see.
Yeah, this one's a little different because you're solving, because like x is usually horizontal and y. That's why they generally in your problem, that's why they chose, sorry, let me scroll up here. They chose they chose the river to go vertically so that your x's and the y's were like this.
Oh, okay.
All right, now this is a graph of a parabola and it goes up like this. So we need to find the vertex. I remember we talked about using formulas. So x equals minus b over 2a. I know this is a y, but you can essentially treat this like x for the time being. So this is minus 200 over 2 times minus 2. So that equals minus 200 over minus 4, which equals 50. So 50 is this place right here. And since we were doing it for y is 50. Okay. Now what is x? X is 200 minus 2y. What's the y value? It's 50. Okay, so x equals 200 minus 100, which equals 100. So if we go back to our drawing now, we know that x is 100 and y is 50. And the area is x times y. So if it asked for the area, it's 100 times 50 or 5,000, whatever, meters squared, I guess. Is there anything you'd like me to cover again on this one?
No, that makes sense now.
So you got to know your vertex formula, minus b over 2a. You got to know to put that whatever you find that number back into the other equation to get both values usually. And then you might even have to multiply them together or graph it to get the maximum area. There's really no variation on this problem except this number over here. Like sometimes they give you 400 meters or they give you 1,000 meters of fencing. That's all that changes. The one you did is another variation on it where they give you, they can give you, instead of 3, they can give you like 5 of these. But all it does is change this one number here, this 3.
Okay.
All right. If you look through your notes, is there anything else you'd like us to cover today? If you don't, I've got the question of the week we could look at. We can also stop early. It's totally up to you, whatever you would like to do.
Can we do one more problem like the cylinder? Because I know she kind of rushed through that. That's the least amount of notes that I have.
Sure. Yeah. So the cylinder has a volume that's equal to, wait a second. Yeah. Okay. Sorry. I thought maybe there was some variation. So the volume is pi r squared h. Okay. And they sometimes tell you, and this is where it gets really complicated. They tell you that they have, they'll tell you the volume. They'll say, oh, the volume is, I don't know. Let's go 48 pi. Okay. So if I were to put 48 pi into this equation, you have two variables. Do you see that?
Mm-hmm.
So you can't solve for either of them. But what you can do is sometimes they give you another equation. They tell you that I don't know, they'll tell you like that the label, they have see, I don't even know what so the question that they gave you, they just gave you the value. So let's do the variation. I said, so let's say the radius is equal to the height. All right. So then if you had 48 pi r squared, well, h is really r, so there's another r here. So 48 pi equals pi r cubed. You can divide both sides by pi, and 48 equals r cubed. So r equals the cube root of 48. All right, so that's like one possible variation on it. Let me see if we can come up with another one. Let me do a quick search here to find volume optimization can problem. Okay, let's see if we can find. Okay. So here's the more realistic problem that you're going to have here. Let me grab, this actually is really a good question here for us to look at. This is probably what your teacher meant. I don't know. It seems like it got cut off. So they tell you a cylindrical can is to have a volume of 400 centimeters cubed. Find the dimensions, height, and radius of the can so as to minimize its total surface area. Okay. The surface area comprises the top and bottom and the lateral surface area. So you already know this. You already know that the volume is pi r squared h. And they're telling you right here, 400 equals pi r squared h. Okay, but here's the difference. This time you're minimizing surface area. So let me snip in this picture because I think this is really helpful. The surface area, there's the can, there's the volume of the can. We've looked at that a couple of times, but here's the surface area. The surface area is the, I call this the label. And this is the top and the bottom. So the surface area is the label plus 2 times the top. So the area of the label is 2 pi r h, and the top is 2 pi r squared. Okay. So how many variables are in this equation? 1, 2. And that's why you need another equation. So you solve this one up here, usually solve for height. So when you solve this one for height is 400 divided by pi r squared. You just move the pi r squareds over. Is that okay?
Mm-hmm.
All right. Now, the height is this. So we're going to take this and substitute it in here. Nowhere else. So the surface area is 2 pi r 400 over pi r squared plus 2 pi r squared. Okay. Now notice that this pi cancels this pi, this r cancels with this r. So you get 800 over r plus 2 pi r squared. This one cannot be done with formulas. You have to you have to just graph this one. There's no way to do it with the knowledge you have. Now, instead of R, you would use X in your calculator here. Let me see if I can get a nice graph of this. There it is. Okay. So I got to change my window here. Okay. 0 to like 5. Okay. All right, so let me snip this in so you can see it here. So when you graph it, you get this place where it minimizes. So I graphed this function over here, and you can see right there is the min, and that's the R value. R is 3.99 or approximately 4. Okay, so let's just say R is 4. How would you find the value of H? Well, you'd have to go back up to this equation right here. So H is 400 over pi times 4 squared. So if you've got a calculator handy, that's 400 over 16 pi. And make sure you put everything in the bottom in parentheses. And it ends up being about 7.96. So basically 8, roughly 8. Now I think that's where your instructor was going, and I would probably ask him or her that tomorrow. I'd say, hey, I was working on this problem last night, and it seemed incomplete, and they'll probably tell you, oh yeah, it is incomplete. So. All right, well, that probably takes us to the end of our lesson time here today. I'll send you the notes and the screen recording out shortly. Thanks for scheduling, and I'll see you next time.
Thank you.
You're welcome. Have a great night. Bye now.
Thank you.